Hello students, today we are going to learn about the physics chapter class 9 motion. In this motion chapter we are going to understand about how to prove equation of motion. So let's start with the first equation of motion, that is V is equal to U plus AT. First equation of motion. What is first equation of motion? V is equal to U plus AT. We are going to prove that V is equal to U plus AT. So students, suppose a car moving with initial velocity U. After time t, its final velocity becomes V. Final velocity, that is V. And this is the initial velocity, students. Initial velocity, and this is the time. What I have said? I said that a car moving with initial velocity u, after time t, its final velocity becomes v. As we know from the previous class that acceleration is equal to change in velocity by time, so we will use this formula. Acceleration is equal to change in velocity by time. Students, what is change in velocity? Change in velocity means, here you have learned that car is moving with initial velocity u, after time t, final velocity becomes v. So change in velocity means final velocity minus initial velocity. What the changes in the velocity? So initially the velocity is u and finally the velocity is v. So what is the change between them? That is the change in velocity. Acceleration denoted by a, change in velocity, that is final velocity minus initial by time. Now students, final velocity denoted by v, initial velocity denoted by u. So we can write a is equal to final velocity v, initial velocity u, divided by time, time denoted by t. Now students, we can say cross multiplication v minus u into 1, so v minus u. A and t multiply, then a into t. Now left side it is minus u. When it go right side of equal, then it will be in plus. So v is equal to u plus at, students. So this is the first equation of motion that we have proved. First equation of motion. Yes. So this is the first equation of motion, students. Let's revise once again. Students, we are going to prove the first equation of motion, that is v is equal to u plus at. Suppose when you are writing in a copy, what you have to write in the language. Suppose a car is moving with initial velocity u, after time t, final velocity becomes v. Now in the previous class we have already learned acceleration is equal to change in velocity by time. What is change in velocity? Final velocity minus initial velocity. Final velocity minus initial velocity. So acceleration denoted by a, final velocity denoted by v, initial velocity denoted by u. So here students, we can write a is equal to v minus u by t. From cross multiplication, v minus u multiply with 1, then v minus u, a and t multiply, a into t. Minus u will come right side of equal, then it will be in plus. So this is the first equation of motion, students. V is equal to u plus at. Let's move to the second equation of motion, that is S is equal to ut plus half at square. Second equation of motion, that is S is equal to ut plus half at square. S is equal to ut plus half at square. Students, we are going to prove this equation. Suppose you are writing in a copy, how you will write? There is some language you have to write about this thing. Let's start with that. Suppose this is the path. On this path, a car is moving with initial velocity u with uniform acceleration a. After time t, final velocity becomes v. Suppose the car has covered a distance s. What you have to write in a language? Suppose a car moving with initial velocity u, after time t, final velocity becomes v. It is also moving with the uniform acceleration a. How much distance the car has covered? S. Now students, we have learned in the previous classes average velocity. Average velocity, that is initial velocity plus final velocity that is final velocity divided by 2. So we can write initial velocity denoted by u. This is the initial, this is the initial student velocity, and this is the final velocity. Okay, so what we can say, initial velocity, that is u, final velocity, that is v. So this is the average velocity u plus v by 2. Now after this, one more formula we are doing, student, that is velocity is equal to distance by time. Distance by time. We have already learned this thing in the previous classes. So velocity is equal to distance by time. Let's multiply distance into 1. So it is distance and velocity and time multiply. So it is velocity multiply time. Now distance denoted by s. Velocity, here we will take velocity u plus v by 2. Now many one will ask, sir, that is the average velocity. So here we cannot take initial, we cannot take final. So we are going to take the average velocity, that is u plus v by 2. In place of velocity, we will take u plus v by 2. And time t. Suppose this equation is a, students. This equation is a. Now we have already learned in this class that v is equal to u plus at from first equation of motion. So from first equation of motion, we know that v is equal to u plus at. Now you are able to find v is equal to u plus at. One thing I just want to tell you, students, in this equation, s is equal to ut plus half at square. Now you just tell me v is there. So if I ask from you v is there, you will say no sir, final velocity v is not in this equation. So our motive is to remove this v to find the s is equal to ut plus half at square. So in place of v, we will put the value of u plus at. So in place of this v, we will put the value of v plus ut. So s is equal to u plus v by 2 multiply time. Now in place of v, what we will write, students? Right now we have learned, in place of v, we will write u plus at. U plus at. In place of v, we will write u plus at. Now divide by 2. This multiplication time t. Now u and u will get added. So 2u at divided by 2 multiply t. So here we can say s is equal to 2u multiply with t. So 2ut plus at and t multiply, then you will say at square division, that is 2. Yes students, now we can write like this. Now we can say S is equal to 2ut by 2 plus half at square by 2. Now when you take LCM of these two, you will again get this equation. Okay, so here 2 and 2 get cancelled, so S is equal to ut plus half at square. This is the second equation of motion, student. This is the second equation of motion. Let's revise once again that how we have proved S is equal to ut plus half at square. Yes, second equation of motion, S is equal to ut plus half at square. When you are writing in your note copy, students, you have to mention second equation of motion, S is equal to ut plus half at square. Then you have to draw this diagram, and after drawing the diagram, you have to write language. What language you have to write? A car moving with initial velocity u, after time t, final velocity of the car becomes v, and the uniform acceleration of car is a. Suppose the car has covered a distance s in time t. Then after, we already learned in the previous class, average velocity is equal to initial velocity plus final velocity divided by 2. Now initial velocity is u, final velocity is v, so u plus v by 2. One more formula we have learned in the previous class, velocity is equal to distance by time. So here velocity is equal to distance by time. Cross multiplication, distance into 1, distance. Velocity multiplied with time, so velocity into time. Now in place of velocity, we have to write u plus v by 2. Many one will ask one question, sir, it is neither initial or not final. And that is the reason we have taken the average velocity of initial and final, that is u plus v by 2 in place of velocity. Now time t. From first equation of motion, we know v is equal to u plus at. So in place of this v value, we will put u plus at. In place of this v value, we will put the value u plus at. Now, so u plus v by 2, in place of v, we will put the value of u plus at. U and u will get added, so 2u plus at divided by 2 multiply t. T and 2u multiply, then 2ut, at and t multiply, at square. Now, we can write this like this also. So 2 and 2 will get cancelled, ut plus half at square. This is the second equation of motion, students. Let's move to the third equation of motion. I hope you all are understanding. I hope you all are getting. Let's start with the third equation of motion. Third equation of So this is the third equation of motion, that is v square is equal to u square plus 2as. This equation we are going to prove in this video. Let's start. Suppose a car is moving with initial velocity u. A car is moving with initial velocity u. After time t, final velocity of car becomes v, and uniform acceleration of car is a. Car cover a distance s in time t. When you are writing in the note copy, students, you have to give the heading of this, and after giving the heading, means after writing the heading, you have to draw this diagram. Now after the drawing, you have to write the language. Suppose a car moving with initial velocity u, after time t, final velocity of the car becomes v, moving with an uniform acceleration a. The car is moving with uniform acceleration a. Car cover a distance s in time t. Same process we will use whatever we have used while proving second equation of motion. So as we know, average velocity that is u plus v by 2, students. U plus v by 2, u is initial velocity, v is final velocity. Now as we know, velocity is equal to distance by time. One more formula we are doing, distance by time. Distance by time we are knowing now. So cross multiplication, then we will get distance is equal to velocity multiply time. So students, we have done cross multiplication over here. Distance multiply with 1, so distance, velocity multiply with time, so velocity into time. Now distance denoted by s, in place of velocity we will take u plus v by 2, and in place of time we will take t. One thing I just want to tell you students, in this equation, third equation of motion, v square is equal to u square plus 2s. Now you just tell me, are you finding any time t in this equation? No. So our motive is to remove the value of t and we put the value of t from first equation of motion. So students, suppose this is the equation A, and from first equation of motion students, that is v is equal to u plus at. So can we write like this? U will come this side, then it is minus u, and here it is at. So v minus u, this a will come in denominator and t remains over here. T remains over here students. So what is the t value? T value we have v minus u by a. This is the t value we have find out. Now from here we can write t is equal to v minus u by a. This t value v minus u by a, we will put in the equation a in place of v. So we will write, put the value of t in equation a. So what is the equation? A, s is equal to u plus v by 2, and in place of t, what you will write? V minus u by a. V minus u by a. Students, can we write like this? U plus v, so we can write v plus u also. V plus u also. U plus v, v plus u we can write. V minus u by a. V minus u by a. So here students, we can use one algebraic equation, algebraic formula. What is the algebraic formula we will use? A minus b, a plus b, a minus b is equal to a square minus b square. So what we can do students, here v plus u, v minus u, it is in the form of a plus b and a minus b. So v square minus u square we can say. So here it will be v square minus u square by 2. So s is equal to v square minus u square by, sorry, here 2 and a multiply, so it is 2a. So here 2a. Cross multiplication, v square minus u square is equal to 2as. So v square, this minus u square will go right side of equal, then it will be positive. So u square plus 2as. So this is the third equation of motion students. Third equation of motion. We can write like this, that we have, we can write or imply that sign. So let's revise once again. This is your third equation of motion. Third equation of motion. Let's revise third equation of motion students. Yes. Third equation of motion, v square is equal to u square plus 2as. When you are writing in the copy, give the heading and draw the diagram. After drawing the diagram, you have to write the language. Suppose a car moving with initial velocity u, after time t, the car final velocity becomes v. Car is moving with uniform acceleration a, and lets the car cover distance s in time t. Average velocity we are already knowing, u plus v by 2. U is initial velocity, v is final velocity. And velocity is equal to distance by time. This formula we are also knowing. Cross multiplication, so distance into one distance, velocity into time, like this. Distance is equal to velocity into time. In place of velocity, we will write u plus v by 2. Time t. Now, in place of t, we will put the value of v minus u by a. From first equation of motion, v minus u by a in place of t, we will put here. So, when we put the value of t in place of t, we will put the value of v minus u by a. So, it is in the form of a plus b, a minus b. A plus b, a minus b, algebraic expression a square minus b square. So, from here, we can write v square minus u square. 2 and a multiply, so it is 2a. Now, cross multiplication, v square minus u square multiply with 1, 2a and s multiply, so 2as. So, v square minus u square multiply with 1, v square minus u square, 2a multiply with s, 2as. Minus u square will go that side, so it is plus u square. So, v square is equal to u square plus 2as. So, this is the third equation of motion, students. Thank you for watching this video. Like, subscribe my channel. For more update, we will meet in the next video with the numerical based on the third equation of motion, second equation of motion and first equation of motion. Thank you once again.